Oh, here we are once again. There's my assistant. Caleb, you're supposed to have glasses on. That's a good boy. That's your future son, Rick Moranis. Alright, so this is about expansion, actually thermal expansion. I use this demonstration to relate a lot of different concepts in physics. Well, this is just to give you the idea that materials respond differently and they expand differently. You can relate this to expansion and contraction with springs. Basic idea is that everything really can be modeled as a spring on a small scale. It just depends on how elastic they are. And solid materials tend to be considered not very elastic at all, relatively inelastic. But actually, there are ways to manipulate these and show that they do expand. They can be stretched, quote unquote. What I'm going to do is I'm going to actually heat up these materials and we'll see whether or not they expand. So what I've done is I've clamped down a force probe. I've got it on the 50 Newton range. And there is a steel rod in between. It's okay. Your glasses? I'm sure everybody's going to be very amused. Here, let's put them on your head. That's where they're supposed to protect anyway, right? Probably not. And I have it hooked up, and you can actually see on the LabQuest, it's reading 25, just over 25 newtons. I'm going to zero that out. You can see my magic wand's getting in the way, right? This is a wooden dowel rod, comparable length. And what we're actually going to do is we're going to compare the expansions of these. So let me... That's right. That's where most people put them, unfortunately. Zero out the dual range force probe. Alright, now we're reading a 0 Newton range. And what I'm going to do is I'm actually going to have this. Let me tilt this up. I'm going to have this reading while I blow hot air onto the middle of this. And so the idea again is that this should act like a spring in expansion, right, in stretching, and it should actually press out against both ends, but ultimately we would get a reading from the force probe. So let's try that, and then compare qualitatively a little bit how this would be for the wooden dowel rod. Okay, that's enough time for that. Apparently a neighborhood dog doesn't like the sound. You can see it actually hasn't gone down yet. It's going to slowly bleed this off to the environment. If I had a thermal gun, you would see that it had actually heated up. Oh, thank you. I'll use those glasses. All right, now let's replace this. See how quickly I can do it. Loosened slightly, they weren't precisely the same length. I've got to keep it snug enough that it holds it in there, it doesn't jostle. Okay, so same setup as before, but different material. Let me zero this out. 0, 0. And we try one more time. Completely different material, much less dense, much less material. Think of this on the small scale. going negative as it should now, because it's pushing back into the force probe. Much lower rate of expansion here. You can actually go backward and you can compare the different force values from before. Okay. Now, an interesting thing about this wood is that it actually begins to contract in on itself because we cook the cellulose. At least that's my theory.